During the context switch discussion, we said that P1 and P2 were going back and forth between running and idling. So they were in two states. They were either running or idling. When a process is running, it can be interrupted and context switched. At this point, the process is idle, but it's in what we call a ready state. It is ready to execute, except it is not the current process that is running on the CPU. At some later point, the scheduler would schedule that process again, and it will start executing on the CPU, so it will move into the running state. What other states can a process be in? And how is that determined? To answer that question, let's look at a general illustration of the states that a process is going through throughout its life cycle. Initially, when a process is created, it enters the new state. This is when the OS will perform admission control, and if it's determined that it's okay, the operating system will allocate and initiate a process control block and some initial resources for this process. Provided that there are some minimum available resources, the process is admitted, and at that point, it is ready to start executing. It is ready to start executing, but it isn't actually executing on the CPU. It will have to wait in this ready state until the scheduler is ready to move it into a running state when it schedules it on the CPU. So once the scheduler gives the CPU to a ready process, that ready process is in the running state. And from here, a number of things can happen. First, the running process can be interrupted so that a context switch is performed. This would move the running process back into the ready state. Another possibility is that a running process may need to initiate some longer operation, like reading data from disk, or to wait on some event like a timer or input from a keyboard. At that point, the process enters a waiting state. When the event occurs or the I/O operation completes, the process will become ready again. Finally, when a running process finishes all operations in the program, or when it encounters some kind of error, it will exit. It will return the appropriate exit code, either success or error, and at that point, the process is terminated.